This video is going to show you how to do a ray tracing for a thin lens that's a diverging lens, which is sometimes called a negative lens. So here's going to be my thin lens. There are a couple things. Number one, it's an approximation. So we can take some liberties with what we're doing. The shape of the curves on each side of this lens is going to be the same, and the shape is generated by an arc of a sphere. So spherical mirror is what it's really going for. I've got this line down the middle, this red dotted line. And for our approximation, that's going to be our line of refraction. So our incident ray and our refracted ray will bend right there at that red dotted line. Not at the surface of the lens, which is what really happens, but this is a thin lens it's a spherical thin lens approximation. Alright, so let's see what's going on here. I'm going to have a light source on the left-hand side, and that light source is going to shine light from left to right. The first side of the lens that it hits is called the primary side. When the light leaves the lens, it will be called the secondary side. But this is just the primary side here. First side it hits. Because it's a spherical part of a spherical lens, the radius that made this side is called the primary radius. And since the focus is half the primary radius, this is called the primary focus. So the first side the light hits is the primary side. The radius that made it is the primary radius, and the focus is half the radius, so it's the primary focus. On the other side, the light leaves as the second side of the lens, so we call it the secondary side. It's made by a radius which I'm labeling as r prime, and the focus is half the radius, so I'm calling that the secondary focus. Secondary side, secondary radius, secondary focus. Alright, one thing to note that's different about this and a converging lens. The primary and secondary foci have switched sides. So if you watch the converging lens video, you saw they were on one side, now they've switched the other side. Alright, time to find an object. So here's an object I'll represent with an arrow. The bottom of the object is always going to be drawn down on the principal axis right through the middle of the lens. The rules for drawing the object are the same as they were for a converging lens, so you don't need to memorize something different. But how they're applied, you've got to think about it a little bit. The first rule says the ray is parallel to the principal axis, that's the incident ray, and then it's refracted through the primary focus at the middle. The problem is the primary focus is kind of backwards. So what we're going to use is the primary focus as an aiming tool. So I'll draw the line, and then the refracted ray, I'll extend it so part of it, the virtual side of it, that's that dotted line that I'm showing right here, goes through the primary focus. So if I was using a ruler, I would hold the ruler on the primary focus, and I would hold the ruler up on the refracted line where the blue incident ray hits it. So the primary focus is just used as an aiming tool. Second ray, same rule as first for a converging lens. Goes right through the vertex, straight through. So here it is, right through it. Just a nice long line. Third ray, same as for converging lenses. It's going to go through the secondary focus to the middle of the lens and refracted parallel to the principal axis. Just like the first time, it's really not going to go through that second focus. It's going to use that second focus to help aim. So the first time it was parallel, that we used the primary focus to aim for the refracted ray. This time we're going to use the secondary focus to help us aim for the incident ray. Wow, it's a lot of words there. Coming down towards the incident ray, you can see how I made it kind of faded a little bit. And where it crosses the red dotted line, that's where it goes parallel. So towards the secondary focus, and then parallel to the principal axis once it crosses the red dotted line. You can see once again that I've extended my refracted ray to make that dotted line there. Always do that, because sometimes the image will be created by that dotted line. It takes two of these rays to figure out where the tip of the object is located. But I'm going to go ahead and draw all three. So here's the first, parallel through the primary, or using the primary to help aim. Next one's through the vertex, and then towards the secondary, and then parallel at the refracted ray line. And you can see where they all cross, right there in front of the lens this time. So notice that the image is drawn from where they all cross down to the principal axis. Since my light source is the tip of the object, my image with lines crossed is also the tip of the object. And the bottom of the object is still going down to the principal axis.